Hello everyone, you are watching the 5.8 Factoring Completely Day 1. So we're still factoring, but we are now moving into factoring completely, which means I don't know what. All right, so let's dive right in. Here we have number 1 graphed, both on our calculator, which I'll encourage you to do, and on the graph to the right. But in part B, it says, what are the roots? And in this case, we can see the roots are at x equals 2 and x equals 3. We can see this both on our graph here and on the calculator. All right, so if I were to work backwards, oh, this is so easy. This is like going back to the beginning. So x minus 2 and x minus 3. So if we did it correctly, we should have the two graphs match up. We're going to be good to go. Let's just finish and do this quickly. And we can see that oh no, they're not the same. So our answer is not correct. What? They look really close though, but they're not. Okay, so why is this so sad? Well, because we know more now on how to factor, meaning we have two different ways that we can factor. So I'm going to copy and paste the 2x squared minus 10x plus 12. And let's think here. The first thing that we ever did when we wanted to factor was we pulled out a GCF. OMG. I can pull a 2x out of every single one of my terms. There it is. Okay, so we're going to pull out the GCF and then we're going to factor what's left over here. So we took a 2 out of everything, and now what's left over has to be factored. So we could use the box method to help us, or we might even be able to use the zeros, but I just want to show you how we can use the box method. Notice how I'm going to put in the only things that are in my yellow highlighted section, and then work backwards. So I know x times x is x squared. I know 3 times 2 is 6, but they have to add to a negative 5, so let's make them both negative. So negative 3x and negative 2x add to negative 5x. So my factors are x minus 2 and x minus 3. So this is factored completely. If we add that sneaky little GCF out in front, you're going to see the graphs match up nicely. All right, let's go ahead on to number 2. Now, for time purposes, let's not worry about graphing it and looking at its roots. But what I would like to do is factor this completely. So x to the 4th minus 81. Okay, so x to the 4th minus 81. Well, there's not a GCF here, so let's kind of figure this out. It's probably going to have to break down to this. I'm going to use this space over here to help me factor. We could ignore the other stuff in those parts because we're not going to do it. Okay, so what times what is going to give me x to the 4th, I think x squared and x squared, and then what two numbers multiply to 81? 9 and 9. We want one of them to be positive and the other one to be negative. We want this so that these two terms here in these boxes combined to be nada. So x squared plus 9, x squared minus 9, factor completely, which might mean I think I have to factor these again. All right, so you know what? Let's do another box. Let's do a box for the x squared plus 9. And it's got a group to be 0 x's. All right, so let's see. X times x is x squared. 3 times 3 is 9. They both are positive, so what do we get? 3x and 3x, and that's row, not 0x. All right, so maybe I need to change them both to negatives. Wait. This isn't working. Maybe one of them positive, one of them negative? Well, that will work, but then, wait a minute. Is this x squared plus 9 factorable? The answer is no. Let's copy and paste it. So sometimes parts can't be factored, but you know what? This x squared minus 9 can be factored because look over here. -3 times +3 is -9, what I was looking for over here. So I was able to kind of do a 2-for-1 deal, which I like. So x plus 3 and x minus 3. We know we're done because there aren't any other x squared terms available to us. Remember, if you graph the original and the final, the two graphs should match. So this question here kind of taught us to keep factoring until we can't factor anymore. I will tell you that the more questions you do, the better you're going to get at them. So the more practice, the more permanent these types of questions are. All right, let's check it out. 3, 4, 5, and 6. Let's do question 3 together. So first thing that we need to do, check for a GCF. And by gosh, by golly, I found it. It's an x. I can pull an x out, and I'm left with x squared plus 8x plus 16. Then what's left over, I'm going to try to factor that again, and that's when I'm going to set up my box. Okay, so there's a trinomial, no more GCF, but we have x squared, so we're going to type in the box or write in the box what's left over, x squared plus 16 plus the 8x. So let's figure it out. X times x is x squared. What two numbers are going to multiply to 16 but add to 8? Oh, that's plus 4 and plus 4. Oh, how fun. But you know what? When we put those up there, you might also realize that this can be written as x all times x plus 4 squared because there's two of them. So your answer could be this or that. Okay, let's go on to the next one. What question are we on? Why is my screen not scrolling over? We'll just do it with the mouse. All right, here we are. X to the 4th minus 2x squared plus 1. All right, checking for a GCF. Always going to do that first. No GCF. So it must be this template. So let's figure out what is going on in there. To figure out what's going on, we're going to set up the box. X to the 4th plus 1. They have to add to -2x squared. All right, what do we have going on here? X squared and x squared. I'm feeling this. Well, it's a -2x squared, so what is this? -1 plus 1? So this is a positive x squared. No. That's not positive 1 minus 1. You're right, silly. This should be -1 minus 1. I lost my box. So -1x squared minus 1x squared. Both of those combine to that. Yes, I found it. Okay, this is weird. X squared minus 1, x squared minus 1. All right, I want you to try factoring this on your own. So go ahead, pause the video, All right, here we are. I got x squared minus 1 to factor. So you want to know what that means? Since they're both x minus 1s, I'm going to do a double skeleton for the first binomial and a double skeleton for the second one, and then they both factor to x plus 1, x minus 1. That is my final answer. All right, pause the video and try the next two totally on your own. All right, so here are the answers to the last two questions, 5 and 6. In summary, we always want to check for a GCF first. We then want to assess the situation to see if we have factored it completely. If it's not factored completely, you're probably going to see a squared in here or have a plus in between. Then we're going to utilize our box method. You can still work on your calculators to find the zeros, but I really at this point think that we should be breaking free from that. Okay, so those are some things. This is kind of like an important little summary of this lesson. Okay, another thing to remember is the GCF never disappears. It comes along for the ride and never goes away. And we always want to use the box method to help us factor to make sure that our pieces are always factored